May I request our speaker, Professor Jahnavi Phalkey, to please come onto the stage. So, good afternoon. Our distinguished speaker, Professor Jahnavi Phalkey, Professor Jyotirmay Sharma, Dean, School of Social Sciences, esteemed colleagues from the school and other units in the university, research scholars, students and friends. It's my pleasure to welcome all of you to the School of Social Sciences Golden Jubilee series, lecture series, hosted by the Department of Political Science. We are truly delighted to see all of you here today, especially after what has been a rather busy week for the School of Social Sciences. On Monday, we kicked off our first round of academic writing workshops, which continued through till yesterday. For many of our students, the excitement continues as they look forward to the much anticipated student festival Sukoon this weekend. So despite this packed schedule, your presence here this afternoon is heartening. So on behalf of the school, I extend a warm welcome to each of you. So thank you all once again for being here. It's my distinct privilege and honor to introduce our speaker, Dr. Professor Jahnavi Phalkey. Professor Phalkey is a textbook definition of versatility. She is a historian of science and technology. She's also a documentary filmmaker. She's a professor. She's an author. She's a public speaker and a curator. Professor Phalkey is the author of Atomic State, Big Science in 20th Century. She's also co-edited 2 books, The Science of Giants, China and India in the 20th Century, and also Key Concepts in Modern Indian Studies. She's on the editorial board of the British Journal of History of Science and History and Technology. She's the producer and director of the documentary film called Cyclotron. Her education and career spans across disciplines, institutions, and countries. She read civics and politics at the undergraduate and postgraduate level at the University of Mumbai. Then she followed it up with an MSc in Politics of Asia and Africa at the School of Oriental and African Studies in London. She holds a doctoral degree in the History of Science and Technology from the Georgia Institute of Technology, Atlanta. She has held academic positions at the University of Heidelberg, followed by the Georgia Tech Lorraine, France, Imperial College London, and King's College London. She is the founder-director of the Science Gallery, Bangalore. This interdisciplinary and boundary-breaking nature of her work, combined with the vision of how to take complex science work to the larger public domain, won her the Infosys Prize 2023 in Humanities. Without further ado, please join me in welcoming Professor Jahnavi Phalkey. May I now request Professor Phalkey to deliver the School of Social Sciences Golden Jubilee Lecture, Science and State Formation in 20th Century India. Professor Phalkey.
I'll put it here, it's no problem. Never mind. Thank you very much for the generous welcome and your generous words. Thank you, Jyotirmay and Kailash, for inviting me to speak in such a distinguished series. I feel like an interloper. I also feel like, how should I put it? I feel indulged because I refuse to let go of my academic roots, so to speak. It's been about 6.5 years since I did any amount of, what one might call serious academic work, the kind that everyone in this room does, which is research and teaching, and have been largely doing admin. So it is a privilege, first of all, to be on this campus, which I have visited only twice before, both times actually as a student. And also, it's humbling to be invited to speak in the series. Now, Kailash spoke generously about my interdisciplinary, boundary breaking, whatever you might call it, kind of journey. It also means no one's ever quite able to trap you. There are two sides to it. So you never need to know enough of everything, right? Like, so if you fall short for the historians, you say, oh, well, but it's history of science. If you fall short for the political scientists, you're like, oh, but it's, history. And if you fall short for the physicists or physical sciences, it's like, oh, but I'm, from the humanities. So it's a good place to occupy when nobody can trap you. But it also means that you leave practically everybody dissatisfied. That is exactly my intention today. Let me share with you 3 instances in the later half of the 20th century that allow us to see how science and state formation come together. Now, this is something that I myself realize only in hindsight, that I took my training from civics and politics to history of science, to the extent that as I started doing my research in history of science, I found myself increasingly wanting to explore relationships between science and the state, science and democracy. And that has been my journey so far. Well, up until 6.5 years ago, I decided to become an administrator. So here we are, and institution building. That's basically what I do now. So let me start with something that practically everybody in this room is by now familiar with. When I was doing this work, it wasn't such a known story. There were geeks who were sort of, funnily aware of this, aware of the Manhattan Project, but today I don't need to say much because I'm pretty sure almost everyone in this room has seen Oppenheimer. Is there anyone who hasn't? Oh, come on, you should have at least thought before putting up your hand. Look at this, but never mind, we will keep you indulged. So, 1938-39 were critical years for a rather young discipline of experimental nuclear physics. 1932 was the year when the atomic nucleus was split open, but also 2 other discoveries that joined to bring this nascent field of experimental nuclear physics into being. Now, there were physicists across the world, especially in the United States and at Cambridge, at the Cavendish Laboratory, who identified, of course, 1932 as the annus mirabilis for experimental nuclear physics, and were encouraging students from across the world to come spend time and further this discipline. Physicists across the world also thought that if they had to work at the frontiers of the discipline, they should be doing nuclear physics. Now, physics in India at this point of time, and indulge me for a little bit of this background because it will come handy as we move forward. Physics in India, alongside mathematics, is an interesting discipline and domain in India also because during the approximately 200 odd years of imperial rule, when institutions for fundamental research or research in the natural sciences, and to some extent also in the human sciences, was grounded, those were disciplines that were of use or that were adjacent to the maintenance of imperial power. Chemistry, physics, and math broadly lay outside this domain. As a result of which, these 3 disciplines did not get institutionalized, like, say, for example, in the Survey of India, the Zoological Survey of India, the Trigonometrical Survey of India, Botanical Survey of India, Anthropological Survey of India, Archaeological Survey of India. You get the list and you get the drift, right? So these 3 disciplines, for the longest time, were not a part of the imperial state apparatus. For chemistry, that changes towards the end of the 19th century with the discovery of aniline dyes and the German so-called Second Industrial Revolution. But for math and physics, it remains the same. As a result of which, leadership positions or intellectual leadership positions, an expansion of research in these disciplines is open for Indians to take forward in ways in which it is not possible in other disciplines because the leadership is largely held by Europeans in Indian institutions. One indicator of this is that, well, the most dazzling indicator of this is the Nobel Prize in Physics that comes in 1930 to this man here, and after whom the auditorium is named, and to date remains the only Indian Science Nobel laureate who was born here, studied here, and worked here. The other indicators are that of the 10 fellows elected to the Royal Society in the time period roughly between the late 19th century and 1947, 8 are physicists, 1 is a physicist turned statistician, and 1 is a paleobotanist. So that tells us that the eminence in research in the natural sciences that is coming out of India in these years is broadly in these disciplines. So it is important to note this because by the time we reach the 1930s and the middle decades of the 20th century, which is when this fabulous thing, and I say fabulous with acute awareness, of the Manhattan Project is put together, physicists in India are thinking at the frontiers of their discipline. And that has consequences. Those are the consequences that I will speak about. Now, Ernest Lawrence, we saw him in the film as well. That's him, of Norwegian origin. And this is one of the early facilities that he and his colleagues put together at the Rad Lab in Berkeley. They were basically working on cyclotrons, or cyclically accelerating particles to smash them open. The largest one that we know today of the cyclotron principle that was put in place in 1933 by Lawrence is CERN in Geneva. Now, what happened during the Manhattan Project was, well, we all broadly saw why it came into being between 1938 and 39, and I always get the two Ottos mixed up, so don't hold it against me if you actually know the history of physics of this time. 4 German physicists are involved. 2 of them talk about fission, right? Like, so the discovery, as it is called, of fission broadly happens between 1938 and 39. Lisa Meitner and her nephew, and I'm now hopefully getting the right Otto, which is Otto Frisch. The Otto Frisch was the first one, Otto Hahn is the second one. They write a paper which explains the implications of nuclear fission, which means anyone who understands physics or nuclear physics, though not physics, anyone who understands nuclear physics and cosmic ray physics at that moment, which is most of them, they understand the possibility of a nuclear weapon. Now, the minute that is realized, there's a letter from Einstein to the American president, so on and so forth. The Manhattan Project is born. The Manhattan Project is put together. I'll come back to the previous slide. The Manhattan Project is put together across several laboratories, across the territory of the United States and Canada, with some laboratories also in the United Kingdom, employing a huge number of people. But what is it? It is a project to realize the potential atomic weapon, which the potential is not quite known, right? We know it is a possibility, but nobody has made a nuclear bomb before, or an atomic bomb, as it was called then, before. So it is the pursuit of both research and its potential application with the kind of resources that we probably would not, I say probably only because as a historian one has to be careful, we wouldn't have seen this in peacetime. The accelerated pumping in of resources to pursue this idea to its completion so that a bomb would be made before the Germans had the chance to realize one, is a project on an unprecedented scale. It brought together the ambitions of states together with the ambitious curiosity of a bunch of engineers and physicists to realize a rather terrifying weapon, right? So the coming together of the goals of a state, of a bunch of states, actually, in fact, a group of states, and a group of researchers. And these researchers, as we saw in the film, but also if you read, there are actually also murder mysteries about the Los Alamos project, which I have greatly enjoyed reading. What does it mean to actually find a dead body in a project that is a highly secret project where you're making a bomb? Makes for very good reading. Anyway, so the coming together of these two ambitions, wherein at no point before that would physicists have imagined, physicists sitting in university departments no different to a campus of this kind, would have imagined that resources at this scale and people at this scale would be employed and put behind a project to realize or to understand at what point does a reaction go critical, or at what point can you actually realize the explosive capacity of nuclear fission. This was actually fairly, mind-blowing. So, now the thing one of the reasons to have this quote, hopefully you can read it from a book, is to say that the project was at its heart still about pursuing a research option. And there were many people, including Enrico Fermi, who moved to the United States from Italy, who was trying to make a nuclear reactor as a part of this larger project, right? So there were a bunch of research projects that are being funded and supported by the state. Now, how does one understand this? The research is couched both in terms of the realization of the explosive potential, but just before the war, before 1938, the same research is being argued for in terms of medical research. So if you can actually use radioactivity for radiotherapy, making different kinds of isotopes for cancer treatment, that too would be a good use of the cyclotron. So, and the interesting thing that I want us to note here is that Lawrence's brother was a medical doctor, also at Berkeley. And one of the grant proposals that he made was, in fact, to the Tata Trusts, because the Tatas at that point of time, in the in the 1930s, 20s and 30s, were funding leukemia research across the globe. Now, mid-1930s, Indians or Indian physicists, and this person, Meghnad Saha, some of you might recognize him, is one of the many Indian physicists who are at the frontiers of their field. Meghnad Saha, for example, was nominated 3 times for the Nobel Prize. There are different reasons as to why that was not realized, but that's neither here nor there. But what I'm trying to say is that he was recognized as an important person in doing research in astrophysics. He also felt, and he was at that point at the University of mid-1930s at the University of Allahabad, he felt that we needed to do experimental nuclear physics in India. So he sent a student of his, this person here. Some people here might remember Basanti Dulal Nag Chaudhary as a former UGC chairperson, former planning commission person, so on and so forth. But he was Meghnad Saha's student from Allahabad, a notorious student, in fact, because he had charges made by the imperial state against him, and Meghnad Saha was accused of, in fact, hiding so-called seditious students. Nag Chaudhary went to Berkeley to study with Ernest Lawrence. And there are some lovely letters between Nag Chaudhary's father, who's a professor of English, and Ernest Lawrence about, my son is coming there to study. Is he comfortable? is this, the usual sort of things that you don't actually expect to find in an archive at the University of Berkeley, repeating sort of, old patterns of parents being, worried about how their wards are faring abroad. But Nath Chaudhary is at Berkeley during the war, so he's aware of the Manhattan Project. He trains together with others in this extremely factory-like laboratory in Berkeley. And then he comes back to India during the war in 1941-42. More on that later, if anyone wants to know. I needn't have put this. I could have just done that, but I didn't know that. Raman, at that point, the country's, at that point sort of recognized as the preeminent physicist of India, teaching and doing research at the Indian Institute of Science in Bangalore, also comes to the same conclusion. And in fact, his argument is every civilized country has a cyclotron. India should also have one. And we should have nuclear physics happening in India too. This is again in the 1930s, well before the war. Now what he does is he sends another student of his, but this time to the Cavendish at Cambridge. This student, now Krishnan or R.S. Krishnan, has a different trajectory. In that, when he hits Cavendish, the senior physicists at Cavendish, have in fact left England and they are at Chalk River, or basically as a part of the Manhattan Project at Chalk River in Canada, they are doing war, they're contributing to war effort, right? So he becomes literally in charge of the Cambridge cyclotron. He knows how to maintain it, he knows how to run it, he knows how to, he trains a bunch of graduate students on it. In fact, he loses one of his students to an air raid, so on and so forth. So in terms of a hands-on experience of actually knowing how to run, and these are very difficult beasts to run. They're not predictable. It's not like turning on a switch and the machine goes on. They're not black boxes in that sense. So, and then Krishnan also comes back to India during the war, comes back and puts in proposals to establish experimental nuclear physics in Bangalore. So by now we have two labs in the early 40s wanting to set up experimental nuclear facilities in India. What does this have to do with the state? Apart from, of course, the Manhattan Project, which has a lot to do with a bunch of states. We'll come to it in a minute. Homi Jahangir Bhabha. I actually once had someone come to attend my talk thinking I was talking about the Homi Bhabha who's alive. And I guess some people in this room at least will know who he is. So no, this is not Homi K. Bhabha. So Homi Jahangir Bhabha had just about finished his PhD at the University of Cambridge, where R.S. Krishnan had gone to do his PhD. He is in India during wartime. He shows up in Bangalore because that's literally the best department of physics in the country at that point of time. There's a Nobel laureate at its helm. Raman accepts him. He sets up a little unit for the study of cosmic rays because he was a cosmic ray physicist. By now in India, we've almost conflated his identity as if he was a nuclear scientist. He wasn't. He was a cosmic ray physicist. Now, of course, cosmic ray physics stands at the threshold of nuclear physics in that they both study particles, except nuclear physicists study particles in the lab and cosmic ray physicists study them in nature. So here he was in Bangalore. Again, like many of their colleagues, they are all aware broadly of what's happening in the Manhattan Project and the possibility of the atomic bomb. He begins to then think about what it might take to institute in India a center or an institution for the study of fundamental physics. And to sort of distill it or to cut a long story short, he establishes one, or he lays the foundations for one with funding from the Tatas, but also from the government and with other support, even as he is in Bangalore. The institution then moves to Bombay after 1945, but it's grounded while on campus at the Indian Institute of Science in Bangalore. His goal is to establish an institution of physics which will match the scale at which physics will need to be done once the war is over. Because the budgets have gone up, the scale has gone up, the frontiers have been, in a way, conquered, so to speak. If it was what does this mean? If it was peacetime research, that kind of money and that kind of political will would not have been put behind the research. And since that happened, many of the Allied discoveries or much of the Allied research that would have taken years to progress happened fairly rapidly, which meant that anything that had to be done in addition or on top of it would require funding and equipment at a scale at which it wasn't required before the war. So it was no longer about tabletop experiments. It was about large equipment systems with significant amounts of funding, but also another word that comes into regular parlance at this point of time, dual-use technology. So anyone who was able to run a research reactor was technically capable of making an atomic weapon. And that meant, and for some of you who are political scientists in this room, modern nation states retain monopoly over violence or retain monopoly over tools that give you power, and this was the shiniest powerful tool to be had. And that meant that state interest in scientific research by the end of the war was so deeply embedded that there was no way to extricate that from research anymore, which meant that any kind of physics research at the frontiers, in particle physics, in nuclear physics, that had to be done would not be easily possible at a distance from the state. This is not even beginning to take into consideration the scarcity of resources or any such other concerns that would have come into play. We've often heard about the centralization of research in India, of the centralization of state funding of research in India, which had been extended to other disciplines too, but we'll come back to this in a second, because what do we have in 1946, 1 year after the first use of atomic weapons? In 1946, a year before independence and a year after the use of atomic weapons, we have Calcutta, which has by then imported everything from a 50-ton magnet to a bunch of other things from California in order to make build a cyclotron in Calcutta. We have Raman and his student in Bangalore also making proposal after proposal to, by then, what was established as the Council for Scientific and Industrial Research, which is CSIR. We also have an already established Atomic Energy Research Board under the CSIR a year before independence. This cluster of university labs, a national lab system that is only emerging. At this point, there are only 3 labs: the National Physical Laboratory, the National Chemical Laboratory, and the National Metallurgical Laboratory, all 3 established with funding from the Tatas. And the CSIR is basically responsible for war effort. So it's contributing to research that is required for the state to carry out warfare on the Eastern Front. This cluster of people then begins to entertain the idea of what it would mean to conduct nuclear research in an India that was very soon going to be independent. In 1946, already, there's a committee that is headed by Homi Bhabha, together with another person from Wilson College in Bombay called Professor Taylor, E. Taylor, now for heaven knows why, but I've forgotten his name, that you can blame it on my age. So there's something called the Bhabha-Taylor report in 1946, which basically states that the Calcutta laboratory may continue, but it is not going to be a state-funded laboratory. Bangalore does not need a laboratory of this kind. And the only state-funded laboratory for experimental nuclear research will be at what became the Tata Institute of Fundamental Research. In a few years, We have the formation of the atomic energy establishment, Trombe, but we'll come to that in a second. So you have a decision, and that's why the use of the word state formation, because the state is not even fully yet congealed. There isn't even a free state, so to speak, of independent India. But there are decisions that are already being formulated in the context of research in anticipation of a state that will be made. And that is what I mean by science and state formation. I've brought with me 3 examples because this in many ways is what one might call an extreme example. There's a very clear possibility of a dual use technology. There's a very clear need for control or a monopoly over violence, and what I mean by violence is control of violence, right? Or the ability to initiate violence, or for that matter, control and stop violence. So this is an aerial image of the atomic energy establishment in Trombe. Now, why states tend to centralize, states tend to control. And often we've made that argument also, given especially that science funding in a country like India is largely coming from the Indian state. And therefore, the description of how this is managed is one of centralization. And I want us to take a step back from there to look at this very case that we've discussed. The scale of funding has changed. The nature of the research has changed. The American answer to this question, and remember that the United States of America at the end of the war is a country which has significant resources alongside the Soviet Union when compared with anybody else. The Europeans are devastated by the war. India is barely sort of, becoming independent and is owed lots of money, especially by Britain. But essentially, it's a very tenuous situation for India. Now, the American answer was the establishment, at the end of the war, was the establishment of Brookhaven Laboratory and Argonne Laboratory, which was 9 to 10 universities coming together and pooling resources in order to be able to carry out experiments. Because it was no longer easily possible to do cutting-edge research or meaningful research of any kind in a single university, given the scale of funds required. The European answer was CERN, which I spoke about earlier, which is an international coming together for 2 reasons, of course. One, the economies of these countries devastated by war meant that they did not have as much to put into research, because there was the need for reconstruction. But also, given that significant, Central Europe, in Germany, was partly occupied by America and partly occupied by the Soviet Union. And American funds, Marshall funds, were helping reconstruction of Europe. It was not in the interests of the Americans to allow for nuclear research to prosper in European countries where they did not have oversight on it. In fact, Isidore Rabi, the physicist, at some point encouraged the establishment of CERN for the simple reason, once they started realizing, 1949, the Soviets conduct their first nuclear tests, which was something not anticipated by the Americans. So we're already talking about how research, or the ability to do research and produce research outcomes, has become deeply embedded in international or interstate rivalry, right? So 49, once the Soviets have conducted their tests, the Americans realize that they need people to talk to. That's Isidore Rabi's statement. We need people to talk to. Because if you're doing research only by ourselves and talking only to ourselves and not looking at other possibilities, or no one's thinking laterally, or however else you want to talk about. If there aren't different pathways being explored in research, our ability to beat the Soviets is going to go down. And therefore we need the Europeans, who were of course an integral part of the Manhattan Project, to continue to do research, therefore CERN. So money was pumped into CERN for that reason. Of course, in 1957, with the launch of Sputnik, came the second shock, where the Americans then again realized that, that the Soviets were a serious. I mean, we have a deepening Cold War. And by 1964, and this is an important moment, and in fact, Ashish Nandi writes about this in the introduction to Science, Hegemony and Violence. John F. Kennedy, after the launch of Sputnik, declares that the Americans will put a man on the moon. Now, it calls for it's not simple. It's not, these are goals that are deeply embedded inside laboratories. So statist goals are being articulated in outcomes of science, physical sciences and engineering sciences laboratories. And so the coming together of science, scientific research and the state is so strong. And there's another thing that I like to often say, which is that, before the Second World War, one would be hard pressed to find countries that have actually ministries dedicated to science and technology. Starting sort of at the end of the war or after the Second World War, and of course the process was gradual. It's not like, a day after such institutions were established. But after the Second World War, national lab systems, so to speak, CSIR, CSIRO, and CSIR being the Indian, Australian, and the UK ones. But of course, there are similar lab systems across countries. Germany had their own starting after the Second Industrial Revolution, and so on and so forth. But ministries of science and tech became a thing to the point where today I don't know that any country would probably not have a department of or Ministry of Science and Technology. So here we have, just to kind of, speak of the different units of government that come into being because of how research progressed starting in the middle decades of the 20th century. Now I'll come to a second example. This is sort of some borderline dual use, not entirely dual use, quite in the same way. Now this person, Vishnu Madhav Ghadge, was a student of physics from Kolhapur, was interested in fluid dynamics, went to Germany, studied fluid dynamics at the University of Göttingen with Ludwig Prandtl, who at that point was seen as an I'll say this ad nauseum, which is that as historians, not that I'm quite the historian, as you already know, I wear several hats, how is that, wolf in a sheep's clothing kind of thing? So I have several sheep on me. So he studied with Ludwig Prandtl, who's been called the father of the study of aerodynamics. Gets his PhD in the 30s, comes back to India, end of the Second World War. So this is an important moment, right? Not the end of the Second World War, the outbreak of the Second World War. So the middle decades, especially the late 1930s to the mid 1950s, are very, very critical decades for how, in many ways, state institutions get formed, but how also that continues. So continues and has consequences today. So Ghadge comes back, and he comes to he goes to Bangalore to join the Indian Institute of Science, even as Hindustan Aeronautics Limited is being established as a part of the larger project. Now here are again several moving parts to this story. There's Balchand Hirachand, an industrialist, comes from a history of having traded in sugar, among other things, and is interested in setting up an automobile manufacture plant, finds an ally in Vishveshwaraya, who's the Diwan of the Maharaja of Mysore, so a princely state at somewhat of a distance from the imperial state, not entirely, but somewhat. And the war breaks out. At first, the Southeast SEAC. At first, SEAC as it is called, the Southeast Asia Command, thank you, senior moments, number 2 in this lecture. Southeast Asia Command is headed by Lord Mountbatten, or Mountbatten, at first in Colombo and then moved to Bangalore because it is a landlocked area. And what they're essentially doing is, as the Japanese advance towards Burma, they are putting together, well, they need to put together aircraft, right? Like they need to assemble aircraft in order to be able to defend the eastern borders. And so you have an American company, Balchand Hirachand's money, Maharaj of Mysore's money, and the Indian Institute of Science all coming together to service the war effort, so to speak, right? But at the same time, and this is the first aircraft that was designed as a part of that effort. Now, I'll speak to, look at that, right? Like it's all entangled. I'll bring him back in a second. But here you have an industrial unit being set up, the Department of Aeronautics being set up, and a National Aeronautical Laboratory that follows after that. So what is happening here? What we have here is academia, industry, and the state in the form of the military, because the aircraft that are produced at HAL are used by the Indian Air Force. The HT trainer was used for training pilots. And so this is in many ways the second layer on top of what began with the dual-use technology and its connections with the state, or its deeply embedded commitment to reasons of state, so to speak, which are that of creating social order and maintaining power. So if that was about scientific research and the state, now here what you have is scientific research, industry, and the state and coming together, right? So again, agencies of the state, but also reasons and outcomes of statist efforts to create social order, but also political power come together. Now, you asked me about it. Here we are. This is the third case that I want to bring to the table. Now, this is not quite what one might understand very directly as a dual-use technology, because it's not, directly connected to warfare. It's statistics. This is a project that I, in fact, began before moving to Bangalore about 6.5 years ago. Now, Mahalanobis was the 9th person that I spoke about when I spoke about the 10 fellows of the Royal Society elected from India, a physicist turned statistician. In the 1920s and 30s, Mahalanobis set up a laboratory in Calcutta, what he used to call it the statistical laboratory, where they conducted a range of experiments, right? Like on agricultural outputs, on in anthropometry, so measuring skulls and things like that. He even designed an equipment called the profiloscope, which was used in anthropometry. And very, very interesting examples. They also carried out the census, not the entire national census, but a portion of the census during the war, when carrying out an entire census was not possible. What Mahalanobis is doing, to distill it, it's a much longer story, of course, but and a very interesting one too. But what Mahalanobis is doing at this point of time is developing a method, which is, to some of you might be familiar with it, D2, or the measuring of an optimal distance for random sampling. So he's working on developing this method, having studied, having studied the work of others in a similar context, but also using other cases, so to speak. Now, this method becomes critical, again, at independence. And why? A newly formed country needs data in order to carry out governance and government. That data has to be reliable. India was a large country. 1949, so for India, the question in a way became important starting 1947. Another country for which the question became important starting 1949 was China. Now, Malanobis has been in and out of doing work with the imperial state, but also with others. He's working in a lab, so he's essentially sort of a maverick academic. It would be probably interesting for this audience to know, although it's in a manner of trivia, but I think by this time in the lecture, a small trivia might not help. Might help. Freudian slip. Malanobis, together with Meghnad Saha and Satyendranath Bose, carried out or did the first English language translation of Einstein's papers in relativity in Calcutta. So the first English translation of the papers in relativity took place in Calcutta. So that's something interesting to note. Also tells you, where Indian science and Indian scientists were at that point of time. Well, not only that they are tackling papers at the frontier, but they also know German well enough to be actually able to do it, right? So it also tells you what was the language of science, more or less to speak. Today it's English, at that point it was German. But coming back to this. So Malanobis is in and out of government agencies, working with various labs. Now, statistics has been called political arithmetic, right? It's numbers for the state, it's numbers for governance. Today, statistics is seen as a method. But at birth or in its formation or formatively, statistics are numbers for government, for use. Enough said. And so when China and India confront a similar problem in the late 40s, the Chinese take the 100% census way, meaning they want to gather every single data point there is to be gathered for anything. So if it's farms, then every single farm. If it's industry, then every single unit and its outputs, and so on and so forth. And the Indian answer is sampling. Because since the 20s, Malanobis and his lab have developed the method to the point where it's actually now interesting and able to yield useful, reliable data. India at that point, or Indian laboratories, Indian Statistical Laboratory, at that point ISI, now it's Indian Statistical Institute, is seen at the frontier enough that Chinese delegations come and spend time in Calcutta to learn from them, but also statisticians from across the world come and spend time there, including leading names in cybernetics and statistics who come and spend time there. One of the most interesting and rather colorful character who not just visited but stayed there was J.B.S. Haldane, the British scientist who in fact later became an Indian citizen. And I say this again for the second point of trivia in this lecture. One of the studies that Haldane carried out together with the statisticians at ISI was as to why certain caste groups in India have oral hair. And while it's funny and, even I laughed when I first read it, it's about endogamy, right? And the consequences of endogamy and the chances of actually traits repeating. So it's a study in human genetics. Again, to say that these statistical methods being developed at ISI in Calcutta, or Statistical Laboratory, the later ISI in Calcutta, are important for governance. And this then becomes deeply embedded in the state, in the National Sample Survey Organization. The National Sample Survey Organization data was considered sort of among the most robust data sets. People from across the world, again, accessed it, wanted to study it. It was used for implementation of various kinds of policy. People were trained across the country to be able to do this kind of work. Did not sort of happen without contest. In fact, people at the Gokhale Institute in Pune challenged some of the parameters and the methods of how this was being done. But fundamentally, to take a step back, the coming together of a method, of a method developed in the laboratory and in the field, because they did use experimental farms, as one that comes to define a state agency in order to be able to do the work that states do, was something we saw with the establishment of NSSO. So, to kind of try and bring these three cases roughly together. Now, obviously, I haven't been able to speak to each of those in the same amount of detail. You can clearly tell which one is the one I'm most in many ways know it better than the other two, and which one also allows me to make the point actually far better than the other two. But I'm hoping that what I've been able to show is the deeply embedded nature of research carried out either in the lab or in the field, and the implications it has for how a state or agencies of the state are realized, and therefore how a state is formed, and therefore not just the importance but also the criticality of the different registers that need to be studied with equal importance in order to understand state policy. It is not through science policy alone that one understands the relationship between science and the state. It's actually, in fact, far deeper embedded in the nature of the relationship between the laboratory and the field and the offices of government. With that, I'll stop, and hopefully you will have at least a question or two for me. Thank you for your attention.
So thank you very much for that very fascinating lecture. And I think it actually perfectly fits with what we wanted and what the university sort of is looking forward to when we sort of got this institution of eminence. Like, one of the themes that university is mandated to do under this is to bring in a lot of interdisciplinarity, both in teaching and in research. So I think your lecture sort of had that rich thread of interdisciplinarity running through all the three themes that you took between state and science, and in terms of what you finally ended in terms of Sarkar and Vigyan and the field and the lab and so on. So I think it is perfectly fitting into that idea of institution of eminence and what it sort of symbolizes and is emblematic of. So having said that, I hope that this lecture would then sort of lead to people thinking more about, there would be sort of conversations happening between, we have 13 schools here. Hope there would be conversations between different people working on issues. I think there will be ideas that people can take forward, and we should see a lot of discussion happening.
Thank you.
So having said that, now we'll open it up for questions. Please be brief, just state your name and we'll take it forward.
Hello, ma'am. I'm Shakti. I'm doing PhD in history. So I'm working on transport history of the Hyderabad state, which is a princely state. Somehow the archive is very unorganized, and I asked for them files of 1880s. They gave me files of 1940s. And that was a period of the war, Second World War. Yeah. The interesting thing is, the words which came in your lecture also, war efforts. Yeah. So Nizam railway infrastructure was used by the British state in some way to, and then I going through those books, those archives, I took some books on the Second World War period, and Ashiq Ahmad Iqbal has recently published a book on the aeroplanes in the modern history. So yeah, so it talks also about how Nizam was in a state with the science tech infrastructure. In a way, he tries to negotiate. So when you say about state formation, I wanted to know that there is a princely India, and there is a British India. So 40% of India was princely India. And in your second story, there comes Mysore in a way. So I wanted to know a little bit more about this story and this distinction, what princely India was thinking about the science, their ideas.
Thank you, Jahnavi, for the talk. I just wanted to know, I'm a sociologist personally, and I wanted to know that now that you make that connection very clear between the science efforts, the state, and there is this international collaborations also that going towards the war efforts, in today's time, in 75 years down the line, what has changed in this relationship? Yes, between science and the state.
I am Hadi Mohammed from Department of Political Science. My political science professor has taught me that the basic feature of the modern state, as you have mentioned in your lecture, is that the monopoly of state over the force, or the monopoly over the violence. To an extent, it is true that the state has the monopoly over force, but we know that there are many non-state actors, especially the terrorist organization, who owns a lot of weapons or deadly weapons. But when it comes to the nuclear energy or the nuclear weapons, to 100%, the state has complete monopoly over nuclear weapons. I don't know any non-state actor who has access to nuclear energy or nuclear weapons. Why it is something unattainable for those non-state actors, this nuclear energy? Is it a fortunate thing? But why it happened?
We'll take one more question.
Sure.
Yeah. Yeah. Hello. Hello.
No. Go ahead.
Yeah. Hello, Professor. Thank you for such a refreshing lecture. I have a question. In fact, in your presentation, you were trying to give us a picture about, the interlinkages between science and the state in early days of India's independence. And my point is, somewhere India was also facing a large degree of resistance from Western science academia in terms of transfer of technology. If it comes to when you take nuclear technology or space technology. So when we are talking about Indian context and a kind of state monopolizing the science, which is fine, but at the same time, there was also a kind of regulatory restrictions from the Western academia to transfer technology to India. From a global South perspective, India faced a lot of issues pertaining to the transfer of technology, probably starting from 60s because India did not sign nuclear non-proliferation treaty. So how do you look at this particular dynamics between the Western scientific academia and the science in India, or in the sense science in India from a global South perspective? So I think there is a particular kind of duality involved in this particular problem.
Okay, let me start because I'll have several senior moments and I'll forget all the questions. So, if you would, from my archive, right, like my archive of the middle decades of the 20th century and probably a little bit before that, I don't know that the people that I studied would identify with any of the frameworks that you just mentioned. Their struggle, if any, was to stay at the frontiers, right? Like the frontiers of physics, right? So you are sitting in Calcutta, you're sitting in Bangalore, and you're on your way from Bangalore to Bombay, or you are going from Göttingen to Bangalore, or you are going from Cambridge to Calcutta, and you're speaking to the leaders of your field. You count yourself among the leaders of the field. So this framing is not of use, and not of use to them. It is not of use to the archive. The archive doesn't deliver to this framework. The second thing is you're asking about technology. So I'd also ask you to ask all of us, in fact, because this is true across India, but also to some extent in China, where science and technology are spoken, or science and engineering are spoken as if they are the self-same thing. They are not. Right? Because a Raman with R.S. Krishnan sitting in his lab, or a Meghnad Saha with Nag Chaudhary in his lab, or a Homi Jahangir Bhabha with his cosmic ray balloons don't need anyone to transfer things to them for them to be able to do their research. They are themselves sitting at the frontiers and in labs at the frontier. So I think there is something to be captured of that time, which is also why I don't often spend time trying to establish why that is different. I think I'd rather present it for what it is than to kind of use frameworks that have somehow become important today to frame us as sitting in the global South, whatever that means. right? Because now see, export controls. After the Second World War, the Brits were not allowed to use valves that were developed collectively together with the Americans. The British and the Americans together did not allow the French to do X. The atomic nucleus is split open at the Cavendish. That experiment is replicated in Paris, it's replicated in Göttingen, it's replicated elsewhere. It's also replicated in India. Why, at what point does it become important for people who are writing about these things or reflecting upon these things to somehow make a special case for this happening in Calcutta or Bangalore and Bombay? And I'm talking about the period that I know best. I'm not talking about later. I'll come to a comment about that later because he's asked me a question about later. At what point does it become important to frame it as if there is a priori a disadvantage to what's being done here? That disadvantage does come later with export controls and the control of dual-use technologies, sometimes at ridiculous levels where the Americans refuse to sell silk balloons for cosmic ray experiments. At later, they refuse, for example, to share supercomputing technologies, right? But in Bangalore, they did create a flow solver, which was an answer to the Cray machine, for example, right? Now, so there are problems. There is resource scarcity. There is a scarcity of trained personnel starting in the early years of independence, continues to date. How we have shaped our institutions, both in terms of research and training, but how also we've shaped the ecosystem that is required to maintain strong links between industry, academia, and wherever else that might be required. Well, even sort of the cultural world. But these are not the problems. I think this framing, in fact, hampers analytically our ability to understand what's happening on the ground. So I'd urge a serious attention to detail and the archive, be it from 10 years ago or even 2 weeks ago, and allow it to, in a way, emerge things that speak back to how people have thought of themselves, right? Like, I don't blame you for asking this question, because every time I've submitted a manuscript, I've had questions. The one that left me so angry that I kind of didn't know whether to laugh or cry was where someone asked me, it's all right to, we understand when Göttingen wants a cyclotron just like Berkeley does, but why should people in India, in the Fiji Islands and in Tanzania want the same thing? Like, the number of assumptions that one would have to crack in the reviewer's brain was, at that point I was a student, and I didn't have the tools to do that. I mean, today I would probably just write a really response, but never mind. So I think these frameworks are problematic. Frameworks of disadvantage are a problem. They are problematic for allowing us an analysis that gives us useful narratives to act upon our present. So I think we need to do more work on that, is what I would say, right? Like, this framework would be unrecognizable to a Raman, unrecognizable to a Mahalanobis, unrecognizable to a Bhabha or a Sarabhai, right? And hardly any women at that point, unfortunately, but that's what it was. So that's my sort of not so brief but brief answer to your question. Let me take the princely state question next. So I think the relationship. So, there are enough very, very good historians and political scientists who've written about the princely states and the integration integration of states in the creation of India, disintegration too. But in pockets, what you see, right? Like, so the Maharaja of Mysore, for example, had 3 successive divans who were fairly, what one might call, committed to, or who saw themselves committed to bringing in new things, right? Like, or things that were important that would put you in conversation, at par, or allow you to access the benefits of what was being seen as various versions of the industrial revolution, right? So, Diwan Sheshadri Iyer, Diwan Mirza Ismail, and then Diwan Vishweshwaraya. All of them instituted projects that were very interesting in Mysore, for example. The first hydel plant, first electrified street in Asia, so on and so forth, right? Like, and they wanted a Volkswagen-like project for developing automobiles. They didn't eventually, and the Hindustan Aircraft Limited was established, etc. And I'm sure I don't know enough about Hyderabad, but the little stories that one hears from, say, even smaller, relatively smaller kingdoms like Baroda or Junagadh or here or there, one sees that there are pockets when the desire or the aspiration to access what is at the frontier, right? Like, and be it in terms of educational research, be it in terms of educational institutions or formats of education, be it simply in terms of acquiring newest gadgets, from cars to other things, right? Like telescopes and clocks, and this goes back sort of fairly in time, has been there. But I think if you're asking me for a pattern, I don't know enough to draw a pattern for you, but it's clear that the Indian Institute of Science, which was the country's first research institution, was established in Bengaluru eventually because the Maharaja of Mysore gave some 400 acres of land for its establishment. And similarly for the establishment of Hindustan Aircraft Limited, and so on and so forth. So I think the story might not be dissimilar to the stories of smaller princely states in Europe, right? Like where they are trying to create, so, Berlin is trying to become Paris and St. Petersburg is trying to become Paris and so on and so forth. So I think those are those stories of aspiration and being at the cultural and at times also intellectual frontier. This is happening, and this story needs to be written. I don't know that, again, patches it's happened. Like in Ashik Ahmed's book, for example, we see some things about aircrafts, right? Like in civil aviation. There are others who've written about, Vishwesvaraya. Now, Prajit Ramnath's book has come out just literally a few weeks ago, which speaks to Vishwesvaraya's work, but alludes only to the works of the earlier divans, for example, and things like that. But I think a collective story might need to be written. In fact, lots of things need to be written about 20th century India. So it would be something worth exploring, that some degree of aspiration was entertained and invested into, right? Like, because you can't just aspire and then buy a Rolls Royce, right? Like you to build a hydel plant and to electrify a mine and then the street that links or the area that links the two, for example, these require investment, these require funding, so on and so forth. So I think I don't know again to what extent Dinesh Sharma's new book about Hyderabad does anything about this again. I mean, he's written earlier about the outsourcers, was his earlier book, which was about the IT industry. So maybe he's actually looked at some of this. I don't know. I still have to acquire the book. His book is also just came out like 2 weeks ago. So I haven't had the time to read that. Then there was a question about science and the state 75 years after. And what was the fourth question? Non-state actors. Oh, yeah. Okay. So, yeah, 75 years on. So, the slide on Sarkar and Vigyan that I had is, in fact, I mean, I thought I would probably speak to a book that I'm mildly editing, actually, called Sarkar and Vigyan. It is a found manuscript from the late 1960s, written by an American called Ward Morehouse. He wrote this book. He called it Sarkar and Vigyan. It's his title, not mine. By flipping C.P. Snow's or Charles Percy Snow's book, Science and Government, and he makes it government and science, and not just makes it government and science, but also make it Sarkar and Vigyan. So, like it's a double whammy in a way. To speak of the entrenched relationship between government and, scientific research and education in India. 2 or 3 observations that he makes that I'll share with you now. One observation he makes is of bureaucratization of science. So 20 years after independence, what he's talking about is how effectively science and scientific institutions are run like government offices. So a national lab system runs like a set of government offices. So science by protocol, right? And that has, of course, consequences. He calls it bureaucratization. And recently I haven't yet read the book again. I'm confessing to having not read too many books, but that's okay. Because, who has that much time anymore? So there's a book by Karthik Muralidharan called Accelerating India. The title initially didn't make me want to read the book. But then I listened to him and I did go back to the book. There's an observation he makes in there, which speaks back to what Ward Morehouse says. And there's a reason why I'm saying this in order to explain what happens 75 years later. Where he talks about how, he says, Indian bureaucrats are accountable. Unlike the sort of, narrative that we have of unaccountable bureaucrats, he says Indian bureaucracy is accountable, except it's accountable to compliance, not outcomes. Right? And that's interesting, because if you're holding them accountable for compliance, have you done this, that's what they're giving you. Not being held responsible for outcomes. And I think if you take that framework and put it, or if you take that understanding of bureaucratization onto science, then you know exactly what's happening there too. Right? So that's one observation he makes. The second observation he makes is one of the nature of Indian institutions, which is the wrong word. Because what he says is that in India, in the first 20 years after independence, he sees that we have organizations, not institutions. Because the minute the leader disappears or steps down, organizations, if not completely collapse, sort of, dwindle or become less. This is interestingly less the case. And in fact, I was talking to Satiki yesterday at the airport. I completely sort of, because he was talking about institutionalization of political parties. In the absence, so basically highly personalized forms of governance and highly personalized ways of running institutions, to the point where then, and that of course, and therefore India doesn't have institutions, which of course doesn't sit as easily when you talk about bureaucratization and lack of institutionalization in the same breath. Because if it's compliance, then where are the SOPs, or where are the standard operating procedures or checklists or protocols, right? So the precariousness and the ever-changing nature of these protocols is also something that comes through. And the third observation, and there are many, Mr. Robbie, he's got some 10 chapters, is one of the nature of recruitment and, again, highly network-led, social stratification, inflicted, refracted nature of recruitment into these positions as well, all of which impacts science. Now, when I said mildly editing this book, because he left a 500-page manuscript unpublished, his family was not aware of it. I accidentally found it. Now I'm getting it published at the behest of the family. One of the reasons why I haven't been able to publish it is, or rather not publish it, send it off for publication, is because I finished writing the making of the book. So Ward Morehouse's journeys to India, how he did the research, how he put together the manuscript, who were the people he was talking to. So I've done that work. I mean, and I felt really good about it, except the real section that matters for my introducing the book and mildly editing it is why read it now? And that's the section that's giving me the biggest possible heartache. I'm using the excuse of not having enough time as an explanation for it, but it's very hard to say that observations that were true in 1967 and 70 are still true today, and in fact have been exacerbated by other, layers of history and process that have come upon it. So how do you put all of this out into the public domain in a sensible manner such that it's actually taken up seriously, as opposed to just, as opposed to becoming a rant, which I don't think it should become, because this is a very, very serious matter. So 75 years down the line, I think we are probably, how to put this nicely now? I think in the middle decades of the 20th century were better for Indian science than the present largely. That's not to say that things haven't changed and that there aren't islands of excellent work in India now, and that there are not people who recognize this. There are, in fact, people who recognize this very, very solidly and are doing things to change it, so on and so forth. That having said, the sum total of the effect, I would still maintain that the middle decades of the 20th century were better, and things have since then actually become fairly difficult for the researcher in the lab, in the field, on the ground, to be able to do their work as effectively as their predecessors have done. Now, to the last question on the, I should give shorter answers. Non-state actors in nuclear weapons. I mean, it's such a difficult question. I know I'm wearing too many hats, and I know that I claim to be a historian of science also, and I claim to be a curator of science. It's not a question to which it's not a question to which there is an easy answer, right? It's not in the hands of non-state actors because it's been guarded heavily, right? So that's the simplest answer, that the lowest level answer to give. Things have been protected. Countries and rulers have been, ousted on grounds of, on suspicion of having created weapons, right? Or harbored weapons, creation of weapons or acquired weapons or whatnot. I don't quite know what the answer to such a question is, right? Because the only known use of a weapon is, known use of that weapon is by a country that sort of, would not accept the label of a rogue nation, right? And again, I'm being slightly trite here, but not entirely. Do I want that someone has it or doesn't have it? I don't think my opinion, frankly, matters in this, and I don't know that I should have an opinion on this either. What's true is that it's not that difficult to do it, provided you have the resources. But you saw the scale of resources required, the institutions required, the kind of trained people required. And that's probably also why not too many people have it.
Thank you so much for that very fascinating lecture. I was curious that Nehru was conspicuous in his absence from your talk. Is there I was curious as to what were these scientists? It seemed from the story that you narrated that they were acting in an organized fashion with each other. There was thought going on, and there were organizational setups for scientists, and they were working through them. But what were the kind of conversations and relationships that they had with the political leadership in pre-independent, and I would say by proxy, the Indian National Congress, and thereafter the new state? So if you could talk a little about that. That's one. And the other may not be very relevant because you're talking about a certain time period. But this came up from the response that you had to one of the questions about the kind of zeal with which Indian scientists at one particular point in time were working, kind of defying certain, or in their radar disadvantage wasn't figuring out in that particular way. Not in the same way that we think about it now, but that was also to do with the kind of ownership that was coming in and how it was being supported elsewhere. I'm reminded of a couple of decades later, my own research has been on reproductive technology. The fate of one particular scientist who was completely disowned by, the person who actually parallelly discovered in vitro fertilization and died in obscurity because his protocols were not recognized, etc. But a couple of years down the line, another team at the King Edward Memorial College in Bombay was supported and received state patronage. So in terms of looking at a newly independent state which is still coming into its own, what do you think are considerations that are going in terms of supporting or thinking about particular kinds of science that are beneficial? Because you kept referring to dual use. So in terms of use and science for knowledge itself or other kinds of things.
Okay. Okay, let me answer this quickly. Is it okay? Because okay, I'll wait.
Thank you. Actually, my question is with regard to your query on, you brought in the China-India dimension. I work on that part. And I remember reading Arnab's thesis on making it count. And so he shared even one of your articles that you wrote on the cyclotron on, So my question is because like the Chinese were learning and they knew that the Soviet model of statistical modeling was like not helping them at all. And now they come to India and they're learning with PC Mahalanobis and all. So today we see at this juncture that we don't trust Chinese data much. And we say they manufacture data. And today, increasingly, states have weaponized data systems and information. So your comment on these two aspects. Thank you.
Okay.
Hi, just one curiosity. The three cases you mentioned, I remember only two, the statistics and nuclear physics. These are prima facie sciences that looks like abstract and impersonal. And from these, one could guess, given the kind of projects the state was funding, don't they have a particular kind of state in their mind? The nature of the state they were creating. In contrast to the kind of research projects funded by the state nowadays, particular case in context is the Indian knowledge system business now heavily funded by the present Indian state. So these kinds of gives us some clues about the nature of state these people were imagining. In conjunction with this Nehru's constant refusal at the beginning of the Indian national state, refusals to fund say systems like Ayurveda, Unani, because he was calling that they are not properly scientific. So they had a different kind of state, at least, even though it wants to hold power in its hand. Can you speculate into that aspect as well? Thank you.
Hello. Hello, ma'am. This is Neelanjan Banerjee from Political Science. I have two questions. Because many of the post-colonial states lacked scientific skills, they had little bit less in terms of resources also. So do you think just like because science is assisting state formation, science, if the political leadership thinks that we should drive more towards scientific projects, more toward infrastructure, can also undermine a sovereign state formation because the new sovereign state might require people and technological transfers from other states, other developed countries, who can put their own terms and conditions on this new state. So can also this science, this new technology can also undermine state formation itself in terms of sovereignty first. And the second question is, do you think that the scientists, the Indian scientists who were working towards this new state formation, this also goes hand in hand with the rationalization and the reformation of religion? Why I'm saying this, because many of the scientists, including Jagdish Chandra Bose or someone like Prafulla Chandra Roy, many of them were actually members of an organization called the Brahmo Samaj. So what is your take on that? Thank you, ma'am.
Hello. Sorry. Yes, you can... So I'm sorry for asking this question. You can answer it quickly. It hasn't anything to do particularly about your lecture. But still, you say you have a person with many hats. And you are moving from particular fields. You have a background in political science. You have, of course, you have in history of science and all that. And as a student who has a background in history, I'm currently in a second bachelor in comparative politics, and the master remains kind of an open question. I'm just wondering what your thought process in changing the hats and how you end up where you end up. You can, just for a last question. Thank you.
Oh God. Yes, see, a character who also wears many hats is a magician usually, right? Like I wanted to be one probably. I don't know. No, look, these are, I'll begin with this question because it's the easiest to answer compared to all of the other difficult questions. Easiest to answer because it's about my own choices. It's serendipity. It's serendipity. I mean, I walked out I've walked out of things in frustration sometimes, frustration and anger, but sometimes I've walked out because even though, like the last sort of, I had a tenured position, I was, marching on towards sort of endless dullness, supervising students and teaching and retiring probably at the age of 70, which could have gone fairly all right. I know. I'm trying to temper it with laughter. But could have done that. But I think in this case, it was what wasn't, the alternative was compelling in that you don't every day get to build an institution from scratch and design an institution from scratch. And, the question that was asked of me was, when you're 70, will you regret having done this or will you regret not having done this, right? And so then the answer is very clear. You often regret, or you're most likely to regret what you didn't do rather than what you did, is my current belief. I don't know how I'll feel when I'm 70. It's all kind of just, I moved from studying politics to studying history of science because I was very angry with the kind of questions I was expected to answer. And that was very specific to my life, my question, my research. And I wanted to do something that something that was different. And I walked into this program that I knew nothing about. And that was 24 years ago. And, I haven't regretted a moment of it. I completely love what I do now. So that, and then this recent one was because, this was a new opportunity. So it's really how you weigh your options in life. It's really it's a personal choice. And I think the thing to tell yourself is that, if you have the privilege of changing your mind, you should. And if you have the privilege of changing your mind and you're compelled to change your mind, you should. That's all I would say. For every person, it would be different. And now on to the difficult questions. So let me start with this one. It's not conspicuous by absence or anything of that kind. I mean, this is the first 20 years. Well, I'm speaking about roughly the middle 3 decades of the 20th century. It is a decade of a largely anti-colonial international Congress. It is the decade of the provincial governments and the first government of independent India, led by Jawaharlal Nehru, and together with a range of other people. And I think the industrial, the political, and the intellectual leadership, which includes the scientists, are roughly trying to find their way to the same page, and the ones that I speak about are ones who are on that page, right? Like, if I had to kind of take one step back from these 3 stories, because I wanted to speak about state formation, right? Like, and I think one tenuous, not rigorously sustainable disentanglement that I try to make in my work is that between politics and the state, right? They're not the same thing, as we all, especially political scientists will know that, fairly well. And so, so I wanted to today speak about what it means for the creation of statist agencies and a statist agenda, and what does it mean for that agenda to actually be enacted inside a laboratory, and what does it mean for a research agenda from a lab to make its way into what kinds of state agencies get formed, right? Like, and how does that build that relationship on the periphery, also with industry, but largely between the state and academia. If we go back to specifics, right, like all of the people that I spoke about have close ties with both the Prime Minister Nehru as well as others, starting before independence. In fact, for the money for the Calcutta cyclotron, the letter that goes out to the Tata Trust. So the Birlas have given Meghnad Saha some money, but the money from the Tata Trust comes after Meghnad Saha sends a copy of a magazine of the Rockefeller Foundation, having funded the Berkeley cyclotron, to Nehru, who's at that point sitting in prison, and he writes a letter from there to the Tata Trust saying, Meghnad Saha is trying to do something new. This is something at the frontiers. Please give money. That relationship later becomes more difficult after independence, but the relationship between Bhabha and Nehru and Mahalanobis is one of having gone to the same university. They're all Cambridge graduates at different times, of course, but still they're Cambridge graduates. And one knows the, how do you call it, fraternity of how should I call it, rarefied institutions, right? So there are these relationships are also based on, again, that conversation, right? Like if an atomic bomb was not used at the end of the Second World War, there would not be the same kind of relationship between experimental nuclear physics and the state. And as a relationship, that conversation, I have no idea what Homi Jahangir Bhabha and Jawaharlal Nehru, if they met, ever would talk about with each other. I'm sure they would have lots to talk about to each other. But this is it, right? Like, so I think context matters. In fact, context is the only thing that matters. And similarly with statistics. Similarly with, if it wasn't for the Second World War, Vishnu Madhav Ghatge would come back from Göttingen, having studied aerodynamics, and become a professor of physics somewhere, teach aerodynamics, right? Or fluid dynamics, like his compatriots. So there were two students who went to Göttingen in the 30s. One of them came back and worked with the CPWD, the Central Public Works Department, as a fluid dynamicist working on dams and irrigation. So it's also about why, at what moment are you cutting the slice? What is it that surges to the top and therefore becomes important, and to whom? Because today, for example, if you're looking at research in artificial intelligence and other related fields, algorithms, this, that, and whatever, it's more important to, at this moment, or in the last, especially 5 to 7 years, it's more important to politics than it is to the state. The state, in fact, is at a distance from that research. The state is barely able to handle it and actually formulate a regulatory policy around it, or even grasp, actually, is it even a tool? Whereas politics has run with it. Cambridge Analytica and electoral politics in the United States, right? So it's about when, how, and how these things, the contingency, right, of what is coming together and to what end, that determines what relationships surface as important. I'm pretty sure there were other scientists who were also close enough because of social networks to political leadership at that point of time. But those relationships don't surface in history, in this kind of history as much, or not for the same reasons in any way, right? So I think there's that to be accounted for. So one part was Nehru, the other part was what kind of science gets, So same thing, right? Like, I mean, at independence, which comes literally at the threshold of the use of the bomb, this is important. You're putting together agencies of the government. Statistics is important. Aircrafts for the Air Force, right? But also later for civil aviation. And the algorithm case, I think, just speaks to exactly the point that you wanted sort of answered, I hope. What was now, I've completely forgotten all the other questions. China. China. So I don't know that I understood your question seriously. I mean, Aruna and I have worked together. We'll continue to work together. In fact, I'm hoping that we'll actually build another project on. So we had this collaboration which ran over 5 years. Roughly half of the scholars worked on India, half of the scholars worked on China, and we wrote collaborative papers. Mine was on mine and Zoe Wang's paper was on India's first science plan and China's first science plan. So, you said something interesting, which is that, I mean, of course, the concerns around reliable data in the Soviet Union was, the outcome of concerns around that were famines under Stalin. The concerns around reliable data in China were also similarly related to, among other things, droughts and famines. So which then brings us back to the kind of reliability of data that was produced in India using random sampling and training enumerators, creating sort of methods that were so useful and easily implementable with relative ease on the ground. and contest, right, like and debate, meant that at least for the first 40, 45 odd years, the data was considered by both the producers as well as users as well as observers to be reliable. That's not the case in India today as well, right? Like I don't know that I don't know the statistician. I mean, there are enough and more editorials in the Indian Express that talk about the unreliability of data in India today. I will quickly flip on my historian of science hat and say, don't ask me about today, because I don't know. I genuinely don't know enough to actually claim. But I think the person who you might read usefully to answer that question is Pramit Bhattacharya, a student of mine, who was with the Mint and is now, in fact, writing a book about the Indian statistical system. So if you look at his columns in the Express and in the Mint, he is very carefully and to great detail writing about the concerns behind reliability of data produced in India today. Who else? What else? Yeah. Nature of state. What kinds of nature of the state and what kinds of... I mean, see, if you look at the three cases that I presented, I don't know that you'll find great differences between, well, across the globe, right? Like you might find differences in outcomes, but you might not find significant differences in aspiration, right? Like, I mean, there might be like import substitution or other things or whatnot, but there are certain kinds of technologies that are seen as, there's certain kind of scientific research that is considered important to pursue and certain kinds of technologies that are seen as important to produce. So that thing is there. Now, you should probably explore the work of Rachel Berger from Concordia University, who has written about the number of Ayurvedic and Unani hospitals that were opened in the 1950s and the kind of research that was instituted then. So it's not that, let me put it this way, certain ideas that you're talking about with certain ideas that have come into prominence today as a result of the surge of attention on Indian knowledge systems are not all areas of concern in quite the same way. They've all also not been discredited in quite the same ways over time. So I would say look at Rachel's work, which will tell you how the early governments were thinking about Ayurveda especially, but also to some extent Unani. So I would then again posit, the need to distinguish between what is considered politically desirable and what is a statist agenda, right? Like the statist agenda is provision of hospitals and provision of medical research to a very limited extent. I mean, there is ICMR and so on, but the largest attention is for provision of public health and, reach, disease surveillance, so on and so forth. And the reason why I say this is that I'm not trying to say that politics doesn't mix in with statist agendas. Certain reasons of state are identified through the surge of of politics of the time. And we see that today. And I think it's a hard battle to fight as a historian of science for me, because if you ask me, and I'm pretty sure actually no one in this room will disagree, that we do require actually pretty serious study of knowledge systems that are other than science. I mean, if as a historian of science you ask me, there are different schools of historians of science too, well, at least a couple of them, and where some of us would argue that the history of science begins about 400 to 500 years ago. That's modern science. That's the history. That doesn't mean there weren't knowledge systems before that. That doesn't discredit them entirely. Because even if you look at modern science, ideas have come and gone and ideas have been discredited and newer ideas have come and newer ideas have, and so in a way, one doesn't examine knowledge from the past as a historian, one would want to understand it for how and why it emerged the way it emerged, right? And there is value in wanting to understand that. I'd like to see enough scholars of Sanskrit and Prakrit and Pali and Persian and classical Tamil and classical Kannada sitting and actually understanding how is it that knowledge was produced on the subcontinent. There's a fabulous book recently written by Senthil Babu on the history of mathematics as social practice, using sources, using not Sanskrit but Tamil and other sources and Malayalam sources, right? And how was math education conducted? How was it? Because people were doing math, people were doing astronomy, people were doing a range of other things, right? But then I myself, as a historian of science, would say, well, that, how would nomenclatures matter? How would anachronism matter, etc.? So I think these are debates that are not so easily settled. I think one ought to do one's best to maintain to the extent possible a distinction between the normative and the analytical, no matter how compelled we are at particular moments, to let the normative take precedence, because then we're playing the same game, and I think one shouldn't. Huh? Yeah. So what was your first question?
Undermining of state due to the use of foreign countries.
Okay, yeah. Yeah, see, which state is that sovereign? Yeah. That's a sort of an absolute hermetically sealed sovereignty of a state is an idea, right? It's an idea. It's historically unsustainable, untenable. It's a planet. Borders are drawn and redrawn, and people are killed for it, and people are, whatever. Sometimes you are given money to give birth to new citizens. So there is no such thing as hermetically sealed sovereignty. Borders are, as we know, borders are produced not on land, but in institutions. And those institutions sustain them. And so when you borrow technologies, if you look at the story of a story that I didn't tell today, because it doesn't have relevance to what I was speaking, is the making of India's first jet fighter. Supersonic jet fighter, in fact. It's called an Indian project, an indigenous project. The aircraft designers were mercenary Nazis who were traveling across the world, first to Argentina, then to India, as another team going to Egypt, Indian test pilots going to Egypt, so on and so forth. It's a complicated and interesting story. Not complicated. It's an entangled and interesting story. But at the end of the day, the aircraft was produced on Indian soil. So it's called India's first supersonic jet fighter, an indigenous project. Except people who made it were trained across the world. Designers came from across the world. The tests for the materials were conducted in Switzerland. The test reports are in German, so on and so forth. So what is it that's undermining? I think sovereignty is not undermined as much by processes as it is undermined by intention, right? That might be one thing to bear in mind. I'm going out on several limbs that I don't have right now, but still, doesn't matter. It is undermined sovereignty is undermined when there is a necessity to undermine it, right? Because otherwise, what does one do to maintain it? What are you maintaining as well, right? Your ability to rule, or are you maintaining your borders, or what is it, right? So I think I wouldn't worry about it. Yeah. Now to your question about the Brahmo Samaj and science and religion, I think again, like his question about knowledge systems and, or not knowledge systems, his question about political agendas. Historically, we've had, let me start by saying this. The antithetical or the antagonistic, actually not antithetical, the antagonistic boundary that is drawn between science and religion is historically again not maintainable. Because we have seen across time people who have been practitioners of science who have been religious figures. This is true in the West, this is true in India. People have not seen reason to I wouldn't even use compartmentalized. People, I think, lead fairly wholesome lives. Problematic ones, but wholesome lives. So Newton was sort of fairly religious. There are figures in India who have been fairly religious. So I think there is, so what is it that we are positing against each other? Knowledge that is produced by a method that is also as tenuous an idea as sovereignty. Because, post facto, you can construct a method for everything. Most new research happens with, and that's not to say there isn't rigor. There isn't a rigor on what counts as evidence and things like that, for example. I'm not trying to say science just happens. There is a rigor, but it's not a defined method, right? Like, so so positing a body of knowledge versus a body of what is presented as a way of organizing social order, as a way of asking for belief. It's, I don't quite know what to do with it, right? Because it's like, I've had a colleague, for example, who's a very, very wonderful colleague, actually, a good human being who has written a book about the religious practices of scientists in an Indian institution. And my thing is, like, yes, it's interesting if you want to understand how they negotiate the practice, as opposed to the uninteresting question is why they negotiate the practice, right? Like, we all do sort of fairly bizarre things. These contradictions are fairly artificial. And I think it would be meaningful to allow room to explore that in all its complexity, or not even complexity, all its character, without having framed it already, that this is a problem. So I think it's okay. They were sort of, yeah.
Thank you so much. We have run out of time. So thank you for engaging with those questions. And I think we got 2 for the price of 1. Your answers were very detailed and very informative. So may I now request Dr. Anju Helen Bara to please deliver the vote of thanks.
Good evening. On behalf of the Department of Political Science, School of Social Sciences, first and foremost, I would like to thank our special guest of the day, Professor Jahnavi. She had really touched into some important issues and gave her insightful ideas on a burning issue when we are dealing with important questions like AI. I would also like to express thanks to Professor Jyotirmay Sharma, Dean, School of Social Sciences, who has been working day and night effortlessly to really work together to bring this series and to make it a success. Professor Kailash, who has chaired the session for today, and he has conducted the entire session. A big thanks to the entire team of Department of Political Science. Any event is not success until and unless there are people who are working day and night behind to make it a success. So a special thanks to the staff of Department of Political Science, to the Dean's Office of Political Science, to the School of Social Sciences, and also to the staff of this particular auditorium, C.V. Raman Auditorium, who have been given their support to make this lecture series a success. And most importantly, the student team, the volunteers, who have been with this particular lecture series since the very beginning, who have volunteered and who have worked together to make it a success. So, Rajat, then Dushyant, Satyaki, Chaimong, Prithvi, and there are others. Maybe if I have forgotten to take their names or if I do not know, I apologize. So they have been who have been working together to make this an event. And most importantly, the audience, even though the Sukoon has started, And I think all of you must be waiting to be there, but still you have been here, patiently listening and keeping engaged. And the session went on. Actually, I thought it was meant for an hour, but I think it's going to be 2 hours. So patiently being here, listening and keeping engaged and making this a successful event. So a big round of applause for all the participants and for all those who have been here. Thank you.